Morning students, welcome to this video. This video is in continuation to my previous videos on the topic of Introduction to Trigonometry. In those previous two videos, as far Introduction to Trigonometry is concerned, let's see what we discussed. We discussed the concept of T ratios, the properties of T ratios, different 6 T ratios. We applied those properties to textual sums. That was your first exercise. And in the next video, we have taken the topic of T ratios of specific angles or standard angles. That is 0, 30, 45, 60, and 90. We derived those results and applied them to the textual problems. Now, as for this video is concerned, I will be taking up the subtopic of T ratios of complementary angles. You have already studied complementary angles as far geometry is concerned from grade 8 onwards. Let's try to see how T ratios of complementary angles are related and what's the relation as far those angles are concerned. So our topic for the day is T ratios of complementary angles. If we ask ourselves what we mean by complementary angles, usually when I ask this question to my students, they say complementary angles are those angles that sum up to 90. But this is not the correct definition. Complementary angles are two angles that sum up to 90. Any two angles that sum up to 90 are said to be complementary angles. And two angles that sum up to 180, they are said to be supplementary angles. Now, two angles, their sum is 90. That means both those angles have to be acute. Let's take the case of a right angle triangle. My right angle triangle is ABC, because we are dealing with a right angle triangle as far as trigonometry is concerned. Now, this angle A and this angle C, they are both acute angles, but as for angle sum property, A plus C is 90 because angle B is 90. So I would say in a right angle triangle, two acute angles, they are complementary. They are always complementary. So in triangle ABC, angle A plus angle C is 90. Now, if I denote A by theta, or any letter to denote an angle, so if A is theta, what about C then? So if we solve this equation, angle C will be 90 minus theta. So this angle is 90 minus theta. Theta and 90 minus theta. That means if theta is 30, then 90 minus theta will be 60. If this is 50, this will be 40 and so on. Now we have some results as for theta and 90 minus theta are concerned, because theta and 90 minus theta, they are two complementary angles in the general format. So let's prepare results. I will take T ratios for theta, all 6 T ratios, and all 6 T ratios for 90 minus theta, and try to see what's the relation between these two angles. Now, I will be taking sine of theta. Sine of theta in this case is, as we know, perpendicular by hypotenuse. My perpendicular is BC, and my hypotenuse is AC. What about cos of theta? Cos is based upon hypotenuse, so it will be AB upon AC. Let's move on to the third T ratio, that's tan of theta. Tan of theta is perpendicular upon base. My perpendicular is BC and my base is AB. Now we have the remaining 4 T ratios, remaining 3. My next would be cot of theta. Cot is obviously reciprocal of tan. It's based upon perpendicular. So it will be AB upon AC, AB upon BC. AB upon BC. And cos will give me secant of theta, reciprocal of cos. So this will give me AC upon AB. AC upon AB. Now if I take the last one, that is cosec of theta. My cosec of theta is reciprocal of sine, that is hypotenuse upon perpendicular. That would be AC upon BC. So we have prepared T ratios in terms of the acute angle theta, 6 of them. Now let's take 90 minus theta and take again 6 T ratios and see the relationship for 90 minus theta and theta. Let me take sine 90 minus theta. So sine 90 minus theta will be, in this case, for 90 minus theta, your perpendicular is AB. Sine is perpendicular by hypotenuse, so perpendicular by hypotenuse. So sine 90 minus theta, acute angle is 90 minus theta, that's perpendicular by hypotenuse. Okay, what about cos of theta? Cos of 90 minus theta. It will be cos is base by hypotenuse. In that case, base is my BC and hypotenuse is AC. And what about tan? Tan of 90 minus theta, that is perpendicular upon base, AB upon BC. So, if we just make a comparison between 90 minus theta and theta, see, you have AB, we have to list the remaining three. Let me just work on these three. AB upon AC, we have here AB upon AC. So, that means sine 90 minus theta and cos of theta, they are same. Sine 90 minus theta is equal to cos of theta. I should write this result so that we just summarize it at the end. So I got that sine of 90 minus theta. Its value is same as cos of theta. Now, what about the second result? See, if you see BC upon AC, BC upon AC, you have BC upon AC. So, what does that tell us? Cos 90 minus theta is same as sine of theta. So, we will say the second result, that sine of theta is cos 90 minus theta. So, on the similar lines, you will, if you make a comparison, well, you prepare cot, secant and cosec, we'll get the remaining results, which I'm just going to summarize now. I won't be finding these results. I will summarize the final results. So sine 90 minus theta is same as cos of theta. Theta is acute, and cos of 90 is sine. So sine and cos have a relation. Sine and cos have a relation. In the previous case, sine and cosec had a relation, because sine is a reciprocal of cosec. Sine is 1 upon cosec, cosec is 1 upon sine. But as for complementary angles are concerned, sine is related with cos. How come? Sine of theta is cos 90 minus theta, and cos of theta is sine 90 minus theta. If you remember the T ratios of specific angles in my previous video, we observed that sine 30 was same as cos of 60. Now, working on the same, we'll have cos we wrote, we'll move on to tan. So tan of 90 minus theta will be cot of theta, and cot theta will be tan 90 minus theta. So tan is related with cot as far complementary angles are concerned, and as far reciprocal results are concerned, reciprocal identities, there also tan is related with cot. Tan is 1 upon cot, cot is 1 upon tan. And in case of complementary, tan is related with cot. Tan theta is cot 90 minus theta, and cot theta is tan 90 minus theta. And if we move on to the other result, that would be secant. Secant 90 minus theta will be equal to cosec theta. And cosec 90 minus theta will be sec theta. This I should have written this way. This is similar. Sine 90 minus theta is cot. I should have written cot 90 minus theta is tan. Tan expressed in terms of cot and vice versa. Secant expressed in terms of cosec and vice versa. So these are 6 results as for complementary angles are concerned. But you need to remember, sine and cos have a relation. Tan is related with cot. Secant is related with cosec. But as for your reciprocal results are concerned, secant is related with cos. In this case, secant is related with cosec. So we'll be applying these results as far as textual exercise is concerned. We'll be applying these results that we have derived as far as textual exercise is concerned. So we have exercise 8.3. This is exercise 8.3. You are asked to evaluate. Let me take the first sum. You are asked to evaluate Sine 18 upon cos 72. Sine 18 degrees upon cos of 72 degrees. So T ratios, basically you have a quotient of two T ratios, and the angles involved, both of the angles are acute angles, sine 18 and cos 72. Now, whenever you come across T expressions or trigonometric equations involving angles which are complementary, like 72 and 18, they are complementary. So in that case, we have to make use of these results, complementary angles. Now what you will do, you will have T ratios, two T ratios, sometimes you can have more of them. They could be in quotient, they can be in sum, they can be in difference, they could be in product. Two angles means two T ratios in terms of two angles which are complementary. The operation could be addition, subtraction, multiplication, division, and the angles involved are complementary. In that case, you have to change one of the T ratio, not both of them. Let me change sine of theta, the numerator. So I will use the result sine of theta is cos 90 minus theta. So using result sine theta, theta is your 18, sine theta we know it's cos of 90 minus theta. I can change the denominator also, but you have to change one of it. Let me change the numerator. So sine of 18, 18 is my theta. Using this result, it's cos of 90 minus 18. And denominator is as it is, it's cos of 72. Now simplify the angle, 90 minus 18 is 72, and the denominator is cos of 72, so you get 1. So the value of this expression, trigonometric expression, is 1. So two angles involved were complementary angles, and you have made use of the result based on T ratios of complementary angles. I'm taking one more sum based on this. For example, this is in difference, question number 1, part number 3. It says cos of 48 degrees minus sine of 42. Sine 42. So you have to evaluate cos 48 minus sine 42. Now see, two T ratios, the angles involved 42 and 48, they are complementary. The operation is of subtraction, so you will change one of it. Let's change the first one. I will be changing this. So I'll be using result cos of theta is sine 90 minus theta. Cos changes to sine 90 minus theta. So this cos of 48 will be sine of 90 minus 48. The second T ratio we keep as it is, sine of 42 degrees. This is sine 90 minus 48 is 42. Yeah, it's 42 minus sine of 42. Sine 42 minus sine 42 is 0. So the answer for this is 0. In the previous sum it was 1. Usually questions based on T ratios of complementary angles, they end up with these answers 0, 1, sometimes 2, most of the time. Now, the third part, this was third part. Fourth part is also same. Cosec 31 minus secant 59. So you will use the same logic. I'll move on to question number 2, wherein you have 4 T ratios, but they are in product, and you are asked to prove, asked to show that So we are asked to show that, this is question number 2, part 1. Show that tan 48 into tan 23 degrees into tan 42 into tan 67. You have to prove it's equal to 1. This is first part of question number 2. Second part also on the same lines. So you have product of T ratios. In fact, all T ratios are same. Not necessary always. Now, 4 angles are there, they are all complementary. See, 48 and 42 sum up to 90, they are complementary. And same is for 23 and 67. So I will write those T ratios together, which are expressed in complementary angles. So I'll be taking the left hand side. I have to prove this is equal to 1. So my left hand side will be tan of 48 into tan. I will be writing this with this together, tan of 42, okay, in brackets. Then tan 23 into tan 67. They are in product. Okay. Now these two angles are complementary. Same is for 67 and 23. Now, as I said, same logic, we'll be changing one of the T ratios. So let's change this first one here. Here also we'll change first one. So we'll be using which result? We'll be using tan of theta as we derived it. Tan is cot 90 minus theta. Tan is cot 90 minus theta. So my left hand side is tan is cot of 90 minus 48. My theta is 48. Tan 48, I wrote cot 90 minus 48 into this tan 42 as it is, into tan 42. Then into this will be changed. It will be expressed as cot of 90 minus theta is 23. 90 minus 23 into tan 67 as it is. Now, let's take it further. So this will be cot 90 minus 48 is 42 into tan of 42. This will be cot of 90 minus 23 is 67 into tan 67. Now, if you recollect, tan and cot, they are a reciprocal of each other. Means cot is 1 upon tan. So you could write cot as this cot as 1 upon tan 42 as it is. And this cot will be expressed as 1 upon tan 67 into tan 67. So they will cancel out, and the final answer is 1. That is your right hand side. So we have verified this trigonometric equation. Prove that the product of these 4 T ratios, it is equal to 1. So it's a case of T ratios of complementary angles. We're rubbing this. Second part of the same question is almost same. Let's take it because there's difference. Second part, question number 2. It says cos of 38 into cos of 52 minus sine of 38 into sine of 52. You have to show this is equal to, this difference is equal to 0. Cos 38 into cos 52, these are degrees. Sine 38 into sine 52, you have to show it is equal to 0. So I'll be taking the left hand side. Left hand side is cos 38 into cos of 52 minus sine of 38 into sine of 52. See, we are observing 38 and 52, they are complementary. 52 plus 38 is 90. 38 and 52, same, they are 90. So we are changing one of the T ratios. Let me change the first one here, but also I will change the first one. So cos of theta, I will express in terms of sine. So cos theta is sine 90 minus theta. Cos will be sine of 90 minus theta. Theta is 38 into cos of 52 as it is. Here I am changing the first one. Sine theta will be cos of 90 minus theta into sine of 52. So we are changing one of the T ratios, and your choice which one you are going to change. I am changing the first one. Cos in terms of sine. Cos theta, sine 90 minus theta. This is same. I change the first one, sine theta as cos 90 minus theta. Second one, same. So the next step is sine. Take the difference. 90 minus 38 is 52 into cos of 52. minus this is cos of 90 minus 38 is again 52 into sine of 52 degrees. Now this expression and this expression, they are same. Sine 52 into cos 52, sine 52 into cos 52. They are same, so their difference will be 0, and that is our right hand side. So we have verified that left hand side equal to right hand side. So we are going to the next sum of this exercise. I will be rubbing this. Now this exercise 8.3, it's quite brief, just 7 sums are there. We can easily finish it. My next question is, if tan of 2a is equal to cot a minus 18, so find the value of a. This is question number 3. Tan of 2a is equal to cot of a minus 18. 2a is an acute angle, find the value of a. You are asked to find the value of a. Now 2a is acute, 18 is also acute. If 2a is acute, a is also acute. Now this is an trigonometric equation. T ratios are tan and cot, but tan could be expressed in terms of cot, taking help of the reciprocal result and taking help of the complementary result. I am taking the complementary angle result. So I will express tan in terms of cot. We know tan of theta is cot 90 minus theta. So this tan I am expressing in terms of cot. So this is cot 90 minus theta is my 2a. Tan of theta is cot 90 minus theta. My right hand side is as it is, cot of a minus 18 degrees. So cot of this angle is equal to cot of this angle. If we equate, we will get 90 minus 2a has to be equal to a minus 18. 90 minus 2a is a minus 18. What is this? This is an equation in a single variable a. We will solve it to get the value of a. So adding 18 on both sides. So 90 minus 2a plus 18 will be a minus 18 plus 18, this cancels. So 90 and 18 is 108 minus 2a equal to a. If I transpose directly, I will get 108 equal to a plus 2a. A plus 2a, so 108 is 3a. So that gives me a is equal to 108 upon 3. 3 3 is 9. 6, 18. So A is 36 degree. That means 2A is 72, which is acute. So we have derived the value of A, which was an acute angle, and answer is 36 degrees. So we observe that these sums are quite easy. They are not so difficult. So you expect a 2 to 3 mark sum as far as this exercise is concerned. Simply just remember that these results are to be applied whenever you come across T expressions or T equations in which the angles are complementary angles. You can have more than 2 T ratios. So we'll move on to the next sum. This was my question number 3. I have one more sum, that's question number 4. If tan of A is equal to cot of B, prove that A plus B is 90. Small sum. 4th sum. Tan of A is equal to cot of B. So you have to prove that A plus B is 90. So express tan in terms of cot or cot in terms of tan. So tan would be cot of 90 minus theta. Tan theta result is cot 90 minus theta. So it's 90 minus A. So that is cot of B. That means 90 minus A is equal to B. So adding A on both sides, it will be B plus A. So that means A plus B is 90. Let's see if we have a harder sum. I think that is question number 6. Fifth is also like secant 4a is cosec a minus 20. So you will either express secant in terms of cosec or cosec in terms of secant, then equate the angles. Then there are two more sums as for this exercise concerned. I will be taking the 6th one, then 7th. So I'll be taking question number 6th. It says if ABC are interior angles of a triangle, ABC. ABC are interior angles of a triangle. That means A plus B plus C is given to be 180 degrees. No need to draw the diagram. A, B, C are interior angles of a triangle. So A plus B plus C is 180. You have to prove that sine B plus C upon 2 is equal to cos A by 2. Sine B plus C by 2 is cos A by 2. We can take the left hand side also and work to show it's right hand side, or right hand side, show it's equal to left hand side. Let me take the left hand side. Left hand side is sine of B plus C upon 2. That will be sine. What is B plus C? If you see from this equation, tell me what's B plus C. B plus C will be 180 minus A. So I'm replacing B plus C by 180 minus A. This 2 in the denominator is as it is. So B plus C is 180 minus A. Now further, this will be sine. 2 divides 180, it will be 90, and 2 divides A, it's A upon 2. 180 by 2 is 90 minus A by 2. Now sine 90 minus theta. A by 2 is theta in this case. Sine 90 minus theta is cos of theta, and my theta is A upon 2. That is your right hand side. So we have proved that sine B plus C upon 2 is cos of A by 2, provided A, B, C are angles of a triangle. Any triangle can be right angle triangle. It has to be right angle triangle because you have T ratios, but A plus B plus C is 180 in case of any triangle. Now, we have the last sum of this exercise, and in this case, you have been asked that express sine 67 degrees, which is acute, plus cos 75, that's also acute, in terms of trigonometric ratios of angles between 0 and 45. Now, one point to observe, 67 and 75, they are acute, but they don't sum up to 90. 67 and 75, they don't sum up to 90, but both are acute. So you are asked to express them in terms of angles between 0 and 45. So again, it's a case of complementary angles. Why it's a case of complementary angles? Because the two angles involved, they are not complementary. How could we say? See, complementary angle results, they help you to express an angle. If you have to, like for example, I have cos 60. If I want to express it in terms of a T ratio, but angle has to be of lesser degree, like cos 60 is sine 30. See, cos 60 is equal to sine 30. In short, sine 30 is cos 60. That means if you have a T ratio in terms of an angle, you want to express in terms of an angle that is higher than the given angle. Like 30 you can express in terms of 60, or 60 you can express in terms of 30. This is to be done. This can be done using complementary angles. So we have 67 and 75, and we are asked to express them in terms of angles of lesser value between 0 and 45. So again, it's a case of complementary angles. the last sum of this exercise, express sine 67 plus cos 75 in terms of angles which are between 0 and 45. 0 and 45. So that means we have to change both of them. Previously we have been changing one of the t ratio, but in this case we have to change sine as well as cos, because demand is angles ought to be between 0 and 45. I will use sine theta. Sine theta is cos 90 minus theta, and this cos theta is sine 90 minus theta. The theta is 75 and here theta is 67. Sine theta cos 90 minus theta, cos theta sine 90 minus theta. Now this is cos 10 minus 7, 3, 8 minus 6, 2, 23, plus sine, this is 15, 10 minus 5, 5, 8 minus 7, 1. So we have expressed this expression, which was in terms of 67 and 75, in terms of 23 and 15. And 23 and 15 both lie between 0 and 45. So this was all about complementary angles. Now we'll take up the last exercise of Introduction to Trigonometry. This is the third video as far as Introduction to Trigonometry is concerned. And what we are left with? We are left with trigonometric identities. In short, we call them as T identities. We have different identities, basic being 3 trigonometric identities. We call them as Pythagorean identities, squared results, or standard identities. Those identities we will use to prove the rest of the identities. But let me explain you what we mean by an identity first, and what are the 3 basic identities. Time permits us to complete those basic 3 identities. So we are taking T identities, trigonometric identities, T identities. If you recollect, in grade 9th, we had different algebraic identities as far as the topic polynomials was concerned. You have equations also, you have identities. One famous identity which we have been doing since childhood, that was a plus b, that still is a plus b whole square. That is a square plus 2ab plus b square. This is an identity. Okay. X plus 1 equal to 5. This is not an identity. This is an equation in one variable. What's the difference? As for the first one is concerned, it's an identity, and the second one is an equation. An equation is true for some values of the variable. Like x plus 1 equal to 5. This is an equation. Variable is x. So this is true for some value of the variable. Like if you put x as 4, so 4 plus 1 is 5. So the solution of this equation is x equal to 4. So it has one solution. And if you take other equations, maybe there are more than one solutions. That means an equation is true for selected values of the variable. But if you have an equation which is true for all values of the variable, like this. This is an equation, but true for all values of a and b. You put any value to a and b, left hand side will be equal to right hand side. Like you put a, any value, any real value, a as 3 by 2, b as 1 by 7, left hand side will be equal to right hand side. So this equation is true, it's valid for all values of the variable. So we call this as an identity. And this is true for selected value or values of the variable involved. So that is an equation. So an equation is not an identity, but we can say an identity is always an equation. Identity is at a higher level. So this is an algebraic identity. And we have trigonometric identities. So trigonometric identities will be identities in terms of T ratios, like sine, cos, tan, cot, secant, and cosec. So how many identities could be there? There are so many identities. But the 3 basic are sine square theta plus cos square theta is 1, 1 plus tan square is secant square theta, 1 plus cot square is cosec square theta. So in this video, I will try to prove those 3 results. Those are known as basic 3 identities. So let's first write them. And the angle involved, I'm taking angle as theta. It could be A, it could be alpha. So mostly we take theta. So basic three identities, basic three T identities, trigonometric identities. They are also known as Pythagorean identities also. I should call them as Pythagorean identities. What are they? Let's list them and prove them. My first identity is, first one is sine square theta plus cos square theta is equal to 1. This is first result. Or you could say sine square x plus cos square x is 1. Sine square a plus cos square a is 1. Okay. And what about the next one? Next one is 1 plus tan square theta is secant square theta. And third one is 1 plus cot square theta is cosec square theta. See, all these three results are in terms of the square. That's why they are also known as squared results. So first result is for in terms of sine and cos. Second is in terms of tan and secant. Third is in terms of cot and cosec. Now with passage of time you are just observing that T ratios, they are related with different T ratios. Like in the first case, as far those reciprocal results were concerned, sine was related with cosec. And as for the complementary, sine is related with cos. Here also sine is related with cos. Now tan is related with cot as far complementary angles are concerned. As per reciprocal, again tan related with cot, but in this case tan has a relation with secant. In turn, secant has a relation with tan, but secant is related with cos as per reciprocal results are concerned. Okay, cot is related with tan as per reciprocal results, but in this case cot is related with cosec, and cosec with cot, but cosec is related with sine as per reciprocal. So this way you are observing that the relationship changes as far those 60 ratios are concerned. So we'll be proving these three results. It's quite very easy. You are simply making use of Pythagorean theorem. They're also known as Pythagorean identities. Let me prove the first result. So I'm asked prove sine square theta plus cos square theta is equal to 1. Okay. So what we'll do, we'll take a right angle triangle, ABC. This is a right angle at B. Let me take this angle as theta. And in this right angle triangle, I will apply the Pythagorean theorem. So my solution is like this. Take a right angle triangle ABC, comma, right angle at B. Let angle B be angle A, let angle A be theta. Now what I do, I will apply the Pythagorean theorem in this right angle triangle, or Pythagoras theorem. Apply the Pythagoras theorem. So my Pythagoras theorem is AC square is AB square plus BC square. Famous result. But let me rewrite it. I'll be writing this as AB square plus BC square is AC square. Because if I observe the equation that I have to prove, in that equation on the left hand side I have sum of two terms. There's a sum on the left hand side. That's why I reverse it. Now I do have a sum on the left hand side. AB square plus BC square is AC square. So what you have to prove? You observe your right hand side is 1. So my right hand side is AC square. So AC square is to be made as 1. So what should I do? I will have to divide. So I will divide both sides by AC square so that I prepare 1 on the right hand side. So when I divide both sides, I will get AB square upon AC square plus BC square upon AC square is AC square upon AC square. So this is AB by AC whole square. This will be BC by AC whole square. And this is simply 1 AC square by AC square. So what is AB and AC? If you observe, AB is your base. AB is base. And what is AC? It's hypotenuse. So AC is hypotenuse, so square of that, plus BC is your perpendicular, and AC is again your hypotenuse, square of that, and right hand side is 1. Now what is base upon hypotenuse? This is your cos. Cos is based by hypotenuse. So this is cos of theta, but square of that. And this is perpendicular by hypotenuse, that is sine of theta, but square of that, that is 1. So we have proved that sine square theta plus cos square theta is equal to 1. Now, as far this result is concerned, one thing to be observed, the angle that you have here, same angle has to be here. It's not that sine square theta plus cos square alpha is 1. No. Angle has to be same. If it's in terms of A, sine square A plus cos square A is 1. Sine square x plus cos square x is 1. But as for this identity is concerned, we have two small results which could be derived from this result. So let me write those results, and you have to retain all three results as for the first identity is concerned. Means this identity will give you two smaller results, so total you have 3 results as far as first identity is concerned. So I'm writing those results. Sine square theta plus cos square theta is 1. This could be written the other way as sine square theta is 1 minus cos square theta. Sometimes you could be asked to prove this also. Prove sine square theta is 1 minus cos square theta. So that time you should understand that this is nothing but the famous result sine square plus cos square is 1. Or one more result, cos square theta is 1 minus sine square theta. So cos square could be also written as 1 minus sine square theta. So sine square plus cos square 1, or sine square 1 minus cos square, or cos square 1 minus sine square. If we stretch this further, see what you are going to get. If you take positive square root on both sides, the sine of theta will be 1 minus cos square theta square root of this. And this will give you cos of theta is 1 minus sine square theta square root. So what we have learned? We have learned that sine theta can be expressed as 1 minus cos square theta square root of that. It can be expressed, sine can be expressed in terms of cos, cos can be expressed in terms of sine. So this is to be done if you are clear with this, the main result, sine square theta plus cos square theta is equal to 1. Now, as for the other two results are concerned, they are to be done on the same lines, making use of the Pythagorean theorem, and from them we derive the corresponding results. So we'll take that topic, this T identities, because it requires a one full video of 1 hour. That we'll be taking in the next video. Till then, all the best and happy learning.